Hey guys, welcome to the second part of the exponent laws video. This is going to cover the quotient law and then also using all the laws combined together because that's a more practical use. We're not going to really have like just product or just power. And then we have a couple application problems at the very end. So just like last time, I'm going to go over the law afterwards, but we're going to first explore a little bit. So let's talk about the expression 6 to the 5th divided by 6 squared. Well, 6 to the 5th means that I have 6 times itself 5 times. And then 6 squared means I have 6 times itself twice. Well, I know this is all multiplication, and I also know that 6 divided by 6 is 1. So are there any 6's I could cancel? I can cancel actually 2 of them, because 6 divided by 6 is 1. So what does that leave me with? That leaves me with 6 times itself 3 times in the numerator, and then 1 in the denominator. And this is also known as 6 cubed, because I have 6 times itself 3 times. Yes, it's technically over 1, but it's just like how we don't always write over 1 over everything. So that's the shortcut of writing it. The next example we see here is 15 to the 3rd, which means 15 times itself 3 times, not 13 times, divided by 15 just by itself. And then I also notice that I can cancel out one of them. And that leaves me with 15 times 15 over 1, because 15 divided by 15 is 1, which is in short 15 squared. Lastly, I have x to the 6 divided by x cubed. X to the 6 means I have x times itself 6 times, divided by x times itself 3 times. Well, just like earlier, whoops, I need to do this in green, just to go with my color scheme and everything. Just like earlier, x divided by x is going to be 1, so I can still cancel out some x's. Okay, and that leaves me with x times x in the numerator, and then a 1 in the denominator, which gives me x cubed. So let's zoom out and look at the bigger picture of everything. How can I get from the starting exponents to the end exponent? Starting exponents to the end exponent, starting exponents to the end. And also notice, let me put a 1 here. Also notice how the bases were also the same in every single expression. So what do you think we could do? Well, I could subtract, right? We're subtracting our exponents. 5 minus 2 equals 3. 3 minus 1 is 2, and 6 minus 3 is 3. So we must, we are subtracting the exponents. I skipped a star here. The first star is that we must have same bases. So in order for us to actually divide and simplify our exponents, our bases have to be the same. So what we're really doing here is we're subtracting. And again, I'm going to go over the law at the very end just because it makes things a little bit simpler when I do that. So I'm not going to go over it currently. Now, number 1, we have 6x tenth divided by 3x to the 5th. Now, we are still dividing. So we still have a numerator and a denominator, and they're being divided. Now, do I have any like bases that I could actually divide? Yes, 6 divided by 3. I can divide that. I know that's going to be 2. 6 divided by 3 is 2. Okay. Next, I know that I have same bases. I know that I have same bases here. X to the 10th divided by x to the 5th. Now, yes, I'm dividing the x's, but I'm going to subtract the exponents, right? Because earlier it says we are subtracting the exponents. Yes, we're still dividing. We're dividing the base, but we are subtracting the exponents to get that simplified form. So if I subtract, I get x to the 5th. A common mistake people make is like, oh, we're dividing, so let me do 10 divided by 5. That's 2. That's not correct, because if you were to literally expand everything out, you have x times itself 10 times up here, right? That would mean that I have 10 and then I have 5 in the bottom, and when I cancel, I only have 5 left. So that is a big mistake that we make, so we need to be careful with that. Okay? A quicker way to think about this is, well, 6 divided by 3, yes, it's 2. And then let's look at our x's. Do I have more in the numerator or more in the denominator? I have more in the numerator. So that means that my x to the 5th is going to be in the numerator, and then I'm not going to have any x's in the denominator. And that one's going to be a little bit more applicable on number 2, so we'll talk about that. Okay, number 2. Negative 9 v to the 5th divided by 6 v to the 8th. Well, I know I have some like bases. Now they don't go in evenly, but I can still divide here. Negative 9 divided by 6 is going to be negative 3 over 2. That simplifies to negative 3 over 2. So again, you always want to simplify as much as possible. And I have v to the 8th, or v to the 5th divided by v to the 8th. And yes, we're technically subtracting, but if you think of a shortcut, you can also think about how, well, where do I have more v's, in the numerator or the denominator? I have more in the denominator, so I know that's where they're going to live. They're going to live in the denominator. And how many more do I have? I have 3, because 8 minus 5 is 3. So that's the shortcut. You can just actually do that. You don't even have to think about subtracting. You can just think about, well, where do I have more and what's their difference? Number 3, I have negative 4x cubed y to the 8th divided by 8xy squared. Okay, so I have negative 4 divided by 8. That's going to give me negative 1/2 when I simplify that. I have x cubed divided by x. Remember, same bases may be divided. Well, I technically have a 1 here, so x cubed divided by x to the first is going to be x squared, and that's going to be in the numerator. Again, you're just thinking about where are there more x's, and then how many more are there. Okay, I have y to the 8th divided by y squared. That's going to be y to the 6th, and I'm going to have y to the 6th in the numerator because there are more y's up there. So if I were to write this in a pretty way, this would be negative x squared y to the 6th divided by 2. Yeah, there we go. I'll go ahead and box that. So negative x. So it's just like how we don't write negative 1x, we just write negative x. So that also works. You don't have to write the 1, but you can. All right, number 4. Change my highlighters. Okay, so I'm going to look at my like bases again. I have negative 3 divided by 2 here. That doesn't actually simplify, but I know that I'm going to have a numerator and a denominator. Okay, next I have x to the 10th divided by x cubed. Those are like bases. Where are there more x's? The numerator. And how many more? 7, because 10 minus 3 is 7. The next variable that we're going to look at is, actually that's too similar in color, y to the 3rd. Y to the 3rd doesn't have any like bases anywhere else, so that just actually stays in the numerator, doesn't really do anything. Lastly, I have z to the 5th divided by z to the 7th. I have more z's in the denominator, so I know that's where they're going to live, and I have 2 more, so 7 minus 5 is 2. So again, the law is you're subtracting exponents, but again, the easier way to think about it is, well, where do I have more of that variable, or more of that base? So the quotient law is if I have a to the m divided by a to the n, so same base, different exponents, I'm going to have my base with my exponents being subtracted from each other. So that's the quotient law if you really wanted like the formula, quote unquote. All right, now we're going to put all the rules together. So I have 2x cubed n times 3n squared x to the 3rd power. Well, let's think about this. You always want to simplify as much as possible. So I know in the front I don't really have much to simplify, and I also know that this 3 is not being expressed or going to be distributed to that front part. So I'm going to go ahead and copy this down the way I see it. Nothing else there. And then I'm going to go ahead and simplify the next part by distributing that exponent. And remember, you're not distributing and multiplying to that base. You're distributing it to the exponent. And remember, there's technically a 1 there. So I'm going to have 3 cubed because 1 times 3 is 3. And then I have n to the 6th because 2 times 3 is 6. And then I have x to the 3rd because there's technically a 1 there. All right, now I'm going to go ahead and simplify. I'm going to go ahead and simplify everything. And the only thing I'm simplifying here is the 3 to the 3rd. And that's 27. So I'm not changing anything else. I'm just simplifying that so I have no more exponents that need to be simplified. Okay, this next step I'm going to go ahead and go. So I have 2 times 27. That's going to be 54. Okay, I have x cubed, and then I have x cubed over here. So that's going to be x to the 6th. And we add those because they're the same base. Oops. They're the same base, and we have x cubed times x cubed. So we have 6 x's being multiplied together there. So remember, you can only do same like bases. Sorry, I'm having trouble speaking. N and then n to the 6th. That's going to give me n to the 7th. And you know that you're simplified when there are no more like bases anywhere else that you could simplify. All right, number 2, I have negative a squared b to the 4th times negative 3a to the 4th divided by negative 3ab cubed. Now, just like just like earlier, I'm going to go ahead and simplify this by parts. So I'm not going to look at the denominator for now. I'm just going to look at the numerator and see if I can simplify anything. Well, I notice that there's a -1 here, technically, right? And then a -3 on the other side. So those are like bases that I could multiply together, and that gives me +3. Okay. And then I have a squared and a to the 4th. That's going to be a to the 6th because I can multiply those together. And then this b to the 4th doesn't go with anything else, so this is just going to be by itself over here. And then now now that I'm done simplifying the numerator, I can go ahead and add in the denominator again. So it's going to be divided by -3ab cubed. Okay, so I'm at the point now where I'm going to start simplifying again. Well, I know that 3 divided by -3 is going to be -1, so I'm just going to say -1. And that's technically -1/1, you know. It doesn't really matter. I'm going to keep the -1 for now, just in case I don't have any fractions. But if you want the fraction bar, you can. Next, we are going to do a to the 6th divided by a. That's going to be a to the 5th, because 6 minus 1 is 5. And those are going to be in the numerator, because there's more a's in the numerator. Let's do... Sorry, I'm running out of like color options here. I don't have an orange. Let's use orange. Oh, that looks the same as the other one. Oh, that's because it is. Okay, we have orange, orange. Those are like bases. Where are there more b's? There's more b's in the numerator. Oh, you know, I forgot something. I forgot the 5 on the a. Boop. Okay. There are more a's in the numerator, so you could say b to the 1st because 4 minus 3 is 1, but you don't have to write it. So there actually is nothing in the denominator, so I can get rid of that fraction bar. And that was my final answer. You could also write this as negative a to the 5th times b, so you don't have to have that 1 in the front. Did I do this right? This was a little different from what I had in class, so let's see. Nope, everything looks fine. All right, number 3. 2 times x to the 5th y cubed divided by -2xy to the 3rd power. Just like earlier, I'm going to split this up into 2 parts. And I notice that my numerator can't be simplified because I only have one of every base. So that's going to stay the same, 2x to the 5th y cubed. But the denominator I can actually simplify by distributing this exponent. So I have -2 to the 3rd power. And yes, I'm going to put that in parentheses because that base is negative. Then I have x to the 3rd, and then y to the 3rd. All right. Now, here I'm going to go ahead and just write down everything exactly the way it is. The only thing I'm going to simplify here is that -2 to the 3rd. And then when I put that in the calculator, it gives me -8. So I didn't change anything else. I just simplified that part there. And then here I'm going to start simplifying like bases. So I have 2 divided by -8. So this is still dividing your bases. And that's going to be -1/4 or 1/-4. You know, it doesn't really matter where the negative sign is as long as you have one. The next one that I'm going to simplify is the base of x, which is x to the 5th divided by x cubed. Where are there more x's? More x's in the numerator. And then there's actually 2 more because 5 minus 3 is 2. Lastly, y cubed divided by y cubed. Does that cancel? Yes, that's technically 1, right? 1 divided by 1 is 1. 5 divided by 5 is 1. 8 divided by 8 is 1. X divided by x is 1. So y cubed divided by y cubed is also going to be 1. So that just cancels out and it is just 1. And if you wanted to write this in a simpler way, it would just be -x squared divided by 4. All right, number 4. Find the area of the triangle. Area equals 1/2 base times height. So let's go ahead and indicate where our base is. So our base is going to be at the bottom there, and our height is going to be right there. So using the formula, area equals 1/2 times the base, which is 6x cubed yz to the 4th, times the height, which is 5x to the -1y. Okay, now here you're thinking about like, oh, distribute. But I don't have to distribute because this is all multiplication, right? It's not addition or subtraction. So if I had like 1/2 times x plus 3, then yeah, I'm going to distribute that 1/2 because I have 2 terms. However, there's not really any terms here because it's all multiplication. And we can actually drop our parentheses. And the reason why we're allowed to is because there is no number up here, right? There's technically a 1. And if I were to distribute this 1 to every single term, well, nothing would change. So we can actually just drop these parentheses. So I'm going to go ahead and do that. All right. And then at this step, I'm going to combine my like bases that I could multiply. I could do 1/2 times 6 times 5. And that's going to give me 15. And then I have x cubed. And then another like base would be x to the -1. And 3 plus -1 is going to be x to the 2, x to the squared, because 3 minus 1 is 2. And lastly, I have my base of y. Well, not lastly, actually, y. And then I have another y. Whoops. What are you doing? Notability. Okay. Let me highlight that again. That was weird. So y times y is going to give me y squared. And then lastly, I have a z to the 4th. What color haven't I used? Oh, geez. Lavender? Nope. It gets to be an issue when you use so many colors. Then you're like, what color do I... Okay, so I have z to the 4th. And there's no like basis for that, so that's just going to stay the way it is. So hopefully you see all of that right there. And that is actually your area. So we don't know what x, y, or z are. X, y, or z is. Either way. We don't know what the values of the variables are, so we just leave it that way. Lastly, number 5, if the area of a rectangle is 18a to the 6, b to the 4th, and the height is 3ab squared, what is the base? So area of the rectangle. So it's giving us the area of the rectangle. And I know that the formula for area of a rectangle is area equals length times the width, or base times height, so whichever. So actually in this problem it uses base times height. So I'm going to go ahead and do base times height. Well, it says the area is 18a to the 6, b to the 4th. So I'm going to go ahead and plug that in. 18a 6, b to the 4th equals, the height is 3ab squared. So that means I don't know the base. So the base is something I do not know, but I know the other things. Okay, well, I need the big B blue, to be by itself because I don't know what that dimension is and it's asking me for it. So I am allowed to divide here. I can divide out 3ab squared on both sides. Okay, these 3's and these a's and these b squareds cancel each other out, and now I just have b equals 18a to the 6th, b to the 4th, divided by 3ab squared. Okay, if this is confusing to you, you can also manipulate the formula at the beginning. So let's say you have a equals b times h, and you know that you need to find b, so then just divide the h on both sides. H's will cancel, and I have a divided by h equals b. And then you can just plug in your area and your height there. So if you don't want to do this long process over here, you don't have to. Here's the shorter way, using our little equations. So I'm actually going to make this a different color. Whoops. Just so that we know that's like something else. But it is a different way you could do the problem. All right, here you're gonna use the tools that you've been using, or the knowledge that you already know. I can divide my bases, 18 divided by 3, and that gives me 6 over 1. And then I have a to the 6th divided by a. That's going to be a to the 5th. If there's technically a denominator, then we would have 1 down here right now because we don't have anything down there. And then lastly, we have b to the 4th divided by b squared. Those are like bases, and I have more b's in the numerator, so this is going to stay up with those. And that's actually my value of the base. It's going to be this. That was it. So it wasn't too bad. You just have to know how to set it up. And then I'm going to go ahead and show you the other way if you decided to do the other way. If you did it the other way, you would just have to plug in your area and your height. So you would just have 18 a to the 6th, b to the 4th, divided by 3ab squared. So everything is the same, except you don't have to go through the process of dividing 3ab squared on both sides. So regardless, you'll get the same answer, but that is it for the rest of these notes.